Hi. So for this first article presentation, I'm going to be talking about the article titled A Chinese Alligator in Heliox, Formant Frequencies in a Crocodilian. It was written by Stephen Reber, Takeshi Nishimura, Judith Janish, Mark Robertson, and W. Tecumseh Fitch. It was published in 2015 and it won the 2020 Nobel Prize for Acoustics and I found it on the Improbable Ignoble website that you showed us. So basically an overview of this research is researchers were interested in the vocalizations of non-avian reptiles. In this specific study, they looked at a female Chinese alligator, and they wanted to see whether or not the bellows that these animals made are honest indicators of that animal's body size. So past research on this, there's been a lot of research on avians, birds, and and just other mammals in general. The mating calls and the vocal acoustic signals that they produce have been studied, and these animals produce things called formant frequencies, which are basically resonances produced in the animal's vocal tracts. And when you look at the recording of the frequencies and the sound waves, the formants are the local maximums, and the peaks in this sound production, in the spectrum of the sound that the researchers record. And we know from prior research that this article talked about that there have been a lot of research done on avians and mammals, and these formant frequencies have been ID'd and have been related to showing being an honest indicator of those animals' body size, which is important, especially in mating, as animals typically are more desirable or courtable when they are larger. And this is true for this Chinese alligator that the researchers in this article looked at. The female Chinese alligators only take mates that are larger than themselves. And so that was a big reason to do this research, which I think is understandable, as there have been a lot in the birds and the mammals, but there have really not been any research in the reptile section of animals, and so the researchers were really looking into that. They also hoped that if they could understand the vocal production systems of a little bit more of these alligators, they would perhaps be able to look at the common ancestor of birds and reptiles together and know a little bit more about the communication of the extinct dinosaur ancestors of these animals. But that wasn't talked a ton about in this article. They just touched on it briefly and was like, hey, this is probably something we can look at going forward, but it wasn't the main point of this study. The main point of this study was to they ended with two hypotheses, and the first one was to identify the actually, let me go back, sorry. The study was conducted with one female alligator, and they put her in an airtight chamber that was filled with water, and at times it was filled with ambient air, which is just normal everyday air that we breathe, and sometimes that was filtered out and replaced with heliox, which is a mixture of 88% helium and 12% oxygen. The animal can breathe normally. It doesn't affect their vocalizations or anything, but it alters the speed of sound to be quicker and higher, and so that displaces the distribution of possible formants that these researchers were looking for. So yeah, they induced this female alligator to bellow, make her sounds, and they recorded those signals in both ambient air and the mixture of heliox. And their hypothesis was, once they analyzed that, they wanted to find a main source, ID the main source of that signal, which obviously was going to be the animal itself. And their hypothesis was that regardless of whether the animal was bellowing in ambient air or the mixture of heliox, it was the main source of the signal was going to remain the same. And then their second hypothesis that was like the special one that they were looking at was they wanted to ID and see if there were formants in this animal's bellows, and see if they could really identify like key, like, hey, yes, this is a formant, this is clearly a peak in this vocalization. And their hypothesis was that if those formants were present, they would be significantly different and distributedly different in the mixture of ambient air and the mixture of heliox because of the speed of sound. Yeah. I think they did a good job at explaining it in a way that I could understand. It took me a little bit to really understand, and there were some things that I kind of had to look up and be like, okay, I kind of get this, but I need to figure out 100% what they're talking about, or I'm not gonna get the idea of the research. And I think they did a good job at picking research that was relevant. Obviously it doesn't really help us as humans a whole lot, but it just gives us greater insight on the species that we live with together on the earth, and it gives us a greater insight just into different species and how they vocalize to each other, which I think was it was really cool. It built on what we knew about other animals already having those formants present, and those formants being good indicators of size. And I think they summarized previous research well, and the way in which they conducted their own research ended up being good as well. I think they ended up conducting the research, it went well, and they were able to identify the formants in both the ambient air and the heliox mixture, and they were able to conclude that the formants were good indicators of the alligator's body size. So I think that's everything.